Hello, this is Timothy Wood with Citadel Civil Engineering. This is CIVL202 Statics, and in this lecture, we're going to be learning about how to read our textbook well. Now, the first thing I want y'all to recognize as we think about textbooks and reading, and I know this probably isn't your favorite, but the truth of the matter is someday you're going to be working as an engineer. You're going to be making those big bucks, and your boss is going to come to you and say, here's a problem, fix it. And when you look at the resources available, it's going to turn out there's not a YouTube video for this. There's not an internet forum. And in fact, if there was a YouTube video or an internet forum, you wouldn't be being paid the big bucks to solve it. Instead, what you're going to have access to is books and code that outlay both the theory and the particular things you're going to have to do to make sure that people are safe. And at that point, you're going to want to have the skill of being able to increase your understanding by reading a book. And so it turns out that a great time to learn that skill is not at your first job. It's rather right now in college where you do have resources like a professor and other friends that are learning and YouTube videos and all sorts of sources and resources available to you. And so let's look at how we might do that. Now, one of my favorite books that would outline how to do that is a book called How to Read a Book. It's a book so great you have to read it twice, once to learn how to read a book and then a second time to actually read it. No, all joking aside, it's a little bit thick, around 400 pages. The main meat is in that first 100 pages or so. I recommend it as a great summer reading. It'll walk you through how to increase your understanding by reading. Now, when we do this, it actually breaks down the reading process into 3 steps. The first step is an inspection of the textbook. This is where you're going to go through a book, any book, and decide whether or not it's worth reading. You're going to take a relatively little amount of time, maybe as much as a half hour, and figure out, is this book worth reading? My hope now is in just a minute that you'd actually do that with this textbook, but maybe take like 5, maybe 10 minutes to inspect the textbook. Once you've inspected the textbook and you've decided it is worth reading, that it has information that you need, some understanding you'd like to gain, you're going to interpret the textbook. You're going to seek to understand what the author wanted to communicate. You might have heard about reader response, where you bring ideas to the book. Not applicable here, not applicable generally. The goal is for you to think the author's thoughts after them. So you're going to want to interpret the textbook and come to the conclusion that says, I understand what the author understands or wanted me to understand. From there, once you can say, I can understand, you can do an intellectual critique. Turns out there's actually only 4 ways you can intellectually critique a book once you say you understand it. But those are spoilers. I'm going to let you read the book and figure that out for yourself. Fantastic book, totally worth reading. So let's start this process so that you can do one of the major learning activities in this class, which is to read a book and to show me a level of understanding by taking notes. When you take your own notes, you actually perform something in your brain where it goes from just kind of flowing over you to it becomes yours. So my encouragement is to you to take notes, not so that you can understand the material later, but it's so that you can understand the material now. And there's a couple of different ways we might take the notes. Some guidance is provided on Canvas in various YouTube videos looking at the Cornell method and sketchnoting, all sorts of ways that might help you. So as you even grab your textbook in this video, get out a pad of paper, take some notes. I'm going to ask you to post them anyway, so let's start now. All right, so we're going to start by taking notes. Let's start by inspecting our textbook. Our textbook is Hibbler's Statics. Any edition will do, probably after the 10th edition. It hasn't changed a lot since then. It's got a large number of example problems as well as practice problems. So if you're looking for more practice, which is an important part of learning statics, your textbook has a number of practice homework problems. It's fairly well written. I quite like it. I want you to take your statics book, and I want you to first start by answering a few questions about it. So you're going to be looking at the preface, the introduction, maybe the first chapter, table of contents, those sorts of places. And I want you to start by classifying the book. What is the book about? Where would you find it in the bookstore? Would it be fiction? Would it be nonfiction? Is it theoretical? Is it practical? what kind of book is it? Once we know what kind of book it's about, we want to look at the content and answer, sorry, once we classify the book, we want to ask what is the book about and go through and figure out kind of what major topics are being covered in the book. From there, we want to outline its major parts, see how the author has put the book together to understand what we might learn and when. And then finally, we want to be able to define the author's problem. What is the author attempting to do by writing this book? And at the end of that, hopefully, we're going to find out that we understand a little bit of how it's put together, what we might learn from it, and what the author would have us walk away able to do. So go ahead and pause the video, grab your textbook, take a look through it, make sure that you answer these questions in your notes, and then come back. All right, hopefully you're back and you've inspected the textbook and you've got some answers that we can talk through in class when we meet together. Now, as you did that, it's likely that you saw the table of contents as a way that the content was organized. Let me show you the way that I'm going to organize the content in this class. I'm going to start off with there's kind of three major sets of topics that we're going to cover. We're going to look at forces. We're going to look at areas because statics actually becomes a bit of a grab bag where we pick up some other content that we might need along the way. And then we're going to learn to do that analysis as part of our dialectic stage in the classical model. We're going to start by analyzing particles, and then we're going to go to rigid bodies. And then at the end of the semester, we're going to tack on a couple other terms, a couple other concepts like friction. So this is kind of the roadmap that we'll be following, and we'll work our way through these major topics. And hopefully you can see where these topics match up with chapters in the textbook. And so those pieces will work together. Now, I've just said a lot of terms, particles, forces, rigid bodies. You skim through the textbook and you're like, man, there's a lot of words there that I don't even know. An important part of statics is giving you the vocabulary to be able to have conversations with other engineers and have everybody know what we're talking about. And so let's go ahead and talk about some of that terminology. The first thing to know about is mechanics as a field comes in three major flavors. So what do I mean by mechanics? That's a good question to start with. As we think about our terms, what do I mean by mechanics? Well, if you read your textbook in section 1.1, mechanics, we'll learn that mechanics is the study of forces on bodies. Okay. Well, I just defined one technical term with some more technical terms. We'll come back to that. When we think about mechanics, it actually breaks down into three major subgroups. The first group is rigid bodies, where we're going to pretend that all bodies out there don't flex at all. Statics is one of the subgroups of that, in which we say that rigid bodies don't move. Yay, nothing moves. Statics, here we are, right? Dynamics looks at rigid bodies in motion. So that'll be next semester. The formable bodies say, well, actually, instead of everything being rigid, everything flexes a little bit. And so that's a whole study there looking at mechanics and materials. And then the last major group of mechanics is fluid mechanics, where it kind of runs all over the table. That comes in two classes: incompressible fluids, which is what civil engineers will study when we're looking at channel flow and pipes, as well as what's used in hydraulic systems. And then compressible fluids, which is what powers things like engines and air conditioners. And we'll leave that to the mechanical engineers. So this class, statics, is within the subdiscipline of rigid body mechanics. And so statics is unique in that in statics, we are studying forces on bodies, but those forces are in equilibrium. Forces are in equilibrium. So again, we're trying to define some terms, mechanics and statics, and we've introduced now three new words that also have fairly specific definitions. So a force is a very important concept for all mechanics studies, forces on bodies. A force is simply a push or a pull. Now, in statics and in most mechanics, we don't worry too much about what actually causes the push and pull. Most frequently, it's just contact, two objects pressing against each other. But you can also get forces from things like electromagnetism and different things like that. We'll leave that to the electrical engineers. Maybe some of you mechanical engineers will get excited about that. But forces, that's all about the push and pull. When we talk about bodies, a body, we're talking about it's just a thing, an object. So we could be talking about big bodies, bridges, buildings, that sort of thing. We could be talking about little bodies, bolts, plates. We could be talking about fluids. We could be talking about any sort of thing. So a body, a thing. So push or pull on a thing, forces on bodies. Finally, when we talk about statics, we talk about things being in equilibrium. And when things are in equilibrium, all those forces, when you add them all up, the sum of the forces is equal to 0. Yay, nothing moves. And that's going to cause our acceleration to be equal to 0. So it turns out statics is actually mainly focused on Newton's first and third laws. We'll talk about that later if you don't remember them, but know that that's coming. So equilibrium. And typically, in most engineering applications, not only is acceleration 0, the velocity is also 0. When we say the acceleration is equal to 0, we're saying that the velocity is constant, but in most of our applications, we're going to find that the velocity itself is also 0, meaning, yay, nothing moves. So typically, velocity is equal to 0. And those are the major terms that we're going to need to be able to use in this class. All right. With that in mind, hopefully you've started to crack the cover on your textbook. We're learning some major terminologies, and I look forward to talking to you in class or on the next video. We'll see you then.